Hello and welcome to today's lesson. In this first tutorial, we will be able to identify what a factor is and simplify expressions. So we are in section 8.4 in our textbook, and I'd like to start off with two fractions, 5/6 and 6/8. Now these are not the same numbers. They will never be the same numbers. But I want to show you something because this is what some students mistakenly do. Understand that 5, of course, is 2 plus 3. I know this. You know this. And 6 is 2 plus 4. It has many names, but 2 plus 4 is one of them. If you see a fraction like this, a lot of students think that those 2's can just cancel away. This is absolutely incorrect. You cannot do this. I know I'm going to do this right now to show you that you can't do this. If these 2's did cancel out, then you'd be left with 3/4. But 3/4 and 5/6 absolutely are not the same. Big no. You cannot cancel these 2's out because these 2's are not factors. You can only cancel out factors. So let's look at 6/8. We all know that 6/8 actually reduces, but let's see why. 6 could be written as 2 times 3, and 8 could be written as 2 times 4. Now the question, can I cancel these 2's out? If I cancel these 2's out, then I'm left with 3/4. And guess what? 3/4 is the same thing as 6/8. So this absolutely is fine. The reason why these 2's can cancel away is because they are factors. Only factors can cancel. Only factors. Factors are things that multiply to another thing. Factors are things that multiply. These are not things that multiply. These are called addends. They're things that add to other things. And you cannot cancel out addends. You can only cancel out factors. So that's the name of this chapter, really. Only factors can cancel away. So let's look at our first problem. It's nice that somebody's already factored things for us. I see these parentheses. So things must all be multiplied together. I've got a 2 times an x minus 5 all in the top. And I've got an x minus 5 and an x squared minus 1 multiplied together in the bottom. I know that since x minus 5 is a factor because it's multiplied to something else, and that this x minus 5 is a factor, I can cancel out these common factors. And what am I going to be left with? Well, I've got the 2 times the x, and in the denominator, I've got the x squared minus 1. I don't need parentheses around x squared minus 1 anymore because there's nothing next to it. Are we finished? Can we cancel out anything more? Do you see a common factor that is being multiplied in the top, in the numerator, and in the denominator? I don't. I see an x right here, but I don't see any x's in the denominator. I see an x squared minus 1. That negative sign, this minus sign, is the same thing as this plus sign. They pull the items together. They pull the parts together and make a whole. And unless you can get rid of the entire whole, none of it can go. Now, some of you might be saying, well, wait a minute, x squared minus 1, I know how to factor that. And you're right. Sure, you can factor x squared minus 1 as a difference of two perfect squares into x plus 1 times x minus 1. That's great that you can do that. But it doesn't help you in that there are no common factors still. There's still just a factor of x up top, and now I've got a factor of x plus 1 and a factor of x minus 1. There's still nothing in common. Either one of these is acceptable. I can understand why some people want to factor the denominator. Either one of these answers is absolutely fine. But please understand, you can't cancel anything more out. Let's look at the next one. Example 2. Whoa, we've got a lot of stuff going on in this one. Let's first make sure that everything is being multiplied together. In the top, in the numerator, I've got everything multiplied together. I actually have 8 factors of a. I wrote it as a to the eighth rather than a. I don't know how many a's. I wrote 8 a's. I don't want to do that. I'm going to write it as a to the eighth. In the denominator, I've got 8 times a cubed times b squared times this factor times this factor. So yes, everything is being multiplied together. Let's get rid of common factors. The first thing I see is a squared plus 4. That's common with this a squared plus 4. I'm just going to put a single slash so that goes away. I'm looking at b minus 3. I don't see any other b minus 3's, so that's going to stay. I'm looking at a minus 2. I don't see any other a minus 2's up top, so this is going to stay. I do see a factor of 2, and I see a factor of 8. And I do know that 2/8 can actually reduce. So I can reduce that. 2/8 reduces to 1/4. So I can maybe cancel out the 1, or the 2 to a 1, and the 8 will become a 4. Sure, that's fine. I'm looking at my factors of a. I have 8 of them up here, and I have 3 factors of a in the denominator. So I can cancel out 3 of the a's. All 3 of these go away from 8 of these, leaving 5. This is just our laws of exponents that we have done before. I see factors of b squared, but that doesn't matter because I don't see any b's up top. Okay, let's see what we have left. I know I've got a 1, but I know I have other things in there, so I'm not going to write the 1. I do have a to the 8th, a to the 5th, and that one went away. I do have b minus 3. Now, b minus 3 still needs to be in parentheses since there's something next to it. And I believe that's everything that's in the numerator. Let's see the denominator. I've got my 4. I've got my b squared, and I've got my a minus 2. Okay, let's stop and look at this and make sure we didn't forget anything. Let's see, my numbers are reduced. I don't have any factors of a in the denominator. I don't have any factors of b in the numerator, and the things in parentheses are not the same. So yeah, we're finished. That's all you have to do. Make sure that they're all factors and then cancel out the common factors. Example 3 is something we haven't seen yet in this tutorial. I don't have any factors yet. I don't see anything that's being multiplied together. So I cannot cancel anything yet, not until I've got things that are factored. But it's okay. I can factor this numerator. Hopefully you're seeing the GCF. Whenever there's a binomial, there's probably either a GCF or it's a special pattern. I see the GCF right now. I'm going to pull out the x from that numerator. If I pull out the x from x squared plus x, there's still 1x right left here, or remaining there, and then the plus sign. If I pull the x away from this term, just the 1 remains. And that would be divided by 1 plus x. There's no fact, this is it. 1 plus x is it. You can't factor that anymore. Now that I see that things are being multiplied together right there, now I have factors. So I've got a factor of x, and I've got a factor of x plus 1. Are any of those factors or either of those factors in the denominator? And you say yes. It might not look exactly the same, but x plus 1 and 1 plus x are indeed the same thing because you can flip around a plus sign. That's the commutative property that says I can do that. These factors will go away. The only thing remaining is the x that's in the numerator. I don't need to put it over 1. I'm just going to box it in like that. So sometimes you're going to need to factor, and this is a little GCF problem. Example 4 is similar. I don't have any multipliers yet. I don't have any factors yet. So I'm going to need to factor the numerator. I'm also going to need to factor the denominator. These are both binomials, so it's probably a GCF going on, and that's true. I see that there's an x squared that's being shared, so I'm going to factor out an x squared from the numerator. If I take away the x squared, if I factor that out, I'm left with a w, and then a minus sign, and then a 1. And in the denominator, I see that I can factor out x cubed. And if I factor out an x cubed, I'm left with a 1, and then a minus sign, and then a w. Now let's see what's going on here. Do we have common factors? Well, let's first look at these. I've got x squared, and I've got x cubed. So yes, these are common factors. I have 2 of them here and 3 of them here. So both of these can cancel away with 2 of these, leaving only 1. So I'll have x to the first in the denominator. Let's talk about w minus 1 and 1 minus w. Are those the same things? Is that the same thing as saying x plus 1 and 1 plus x? No, the answer is no. You cannot flip around a minus sign. They're not the same things. If you said 5 minus 1, and 1 minus 5, they're not the same things. But 5 minus 1 and 1 minus 5 actually are opposites. So this is what we can do. We can flip one of these around, and in this case I'm going to flip this one around and make that w minus 1 by understanding that that is going to be the opposite of this. And then I'm going to need a negative sign in my answer. It's sort of like factoring out a negative 1. If I take this 1 minus w and factor out a negative 1 from both of those parts, then this becomes a negative 1, which I'm going to put over here, and this becomes a positive w, which I'm going to put right there. So I can make 1 minus w turn into w minus 1 as long as I understand that there's a negative that's going to be involved. So now 1 minus w is gone, and w minus 1 will take its place as long as I don't forget that minus sign. What I do is I put a minus sign and circle it so I don't forget that. And then I can cancel these factors out because now they will be common as long as I remember that there's a minus sign. So let's see what's left. I have a minus sign. There's nothing else in the numerator, so I have to put the 1. And in the denominator, there's an x. This is our final answer. Please understand that you cannot flip around a minus sign, but you can flip around a plus sign. If you have a plus sign, then you cancel those right out because they're the same things. Minus sign, you can flip it around as long as you remember that there's a minus, a negative that's been factored out. Okay, that's the end of this tutorial on simplifying, and I'll see you in the next tutorial. Bye-bye.